Welcome back. Let's take a look at what it means to be a vertical shift when we're dealing with functions. So we always try to look at this in terms of patterns, but when you first start, as you maybe have tried to do at the first part of the examples, we maybe want to use your TI to explore what is actually happening. So the key here is that you're going to see your original parent graph. In our case, the way we have described it is f of x is the parent graph. And you kind of want to see how it's been modified. So notice we're going to see this plus c or minus c outside of the parent graph. And whenever you do see this, there's an addition or subtraction to or from the outside of the parent graph. You kind of want to go back and understand, well, what does this mean in terms of movement? So if you guys remember just a little bit, try to connect this to something. Remember with ordered pairs, we have x comma y. And usually x, if you're talking about graphing it, it's telling you, I shouldn't use an arrow, I should just kind of say, it's telling you to go left or right. And y is telling you to go up or down. So we kind of remember those when we're plotting ordered pairs. Now, if you think about it, we don't really talk about y as y. We end up replacing it with f of x. Means the same thing. So when you're thinking about what's happening with f of x, you could kind of say, well, it's still an up-down movement. So if you really relate this f of x to what's happening with your numbers, you're really saying y plus c or y minus c. And when you modify the y values, this is why you are going up or down, because y values have up or down movement. So I'll try to plant that seed in your mind. And I know we're a little abstract right now, so I understand it takes a little while to kind of absorb it. But I kind of want to show you a concrete example, as maybe you were playing with in the earlier examples, or kind of the discovery part of this section. Whenever you're a little bit confused about these abstract graphs, because we really don't know what the original function was, like for example 1, you may do like a mini concrete example. So you might want to think about, try f of x being square root of x. And then if they're trying to figure out what's being described, g of x is f of x plus 2. So that's square root of x, and there's a plus 2 on the outside. Well, if you don't understand the pattern or you don't have it quite memorized yet, what you do is pull up the TI. And let's see if we can graph it and see what happens. So we'll do that together. And this is more of discovery. I know in part of the section, it's easier to type in the original functions into the calculator. But when you have these abstract examples, we kind of have to make that connection ourselves. So I'm getting square root of x. That was my parent graph. And my modified function, I believe, was square root of x. And there's a plus 2 on the outside. Very important to understand it's on the outside. So let me zoom it to standard, because maybe my previous function didn't have anything. And we see right away that our original function in blue is the square root of x. And it looks like the red has moved in what direction? And if you said up, you are right. So just kind of a quick concrete way to help us think a little bit harder about these particular abstracts. So that gives me a huge clue about the plus 2 part. The plus 2 is basically telling me to shift f of x vertically upward 2 units. So when you shift vertically upward 2 units, your y values will change. And you don't have to think too hard about it. You can actually see what's happening with your concrete points right here. So I'll do that. We can do this mathematically if we want, and maybe it makes a little more sense later, but I prefer just eyeing it and saying, okay, let's look at -4, -1. And if we're going to shift it up 2 units, we just do counting. Sometimes it's a little nicer when you can concrete draw on the graph itself. So I'll transfer this over to the final draft. My new point would be -4, +1. I'll take the next original point, -1, -2. If I shift it up 2 units, 1, 2. The new point is on the x-axis, -1, 0. We'll copy that over to our final draft. We'll take the third point, 2, 3, shift it up 2 units. And the new point is now at 2, 5. We're going to transfer this over to our final draft. And for +1, we're going to shift that up 2 units, and our new point will be 4, 3. Copy that over to your final draft. So see how the y values have changed. And a lot of times, just so that you can see what really happened with your function, you'll see me kind of do a mini outline. Well, I'll try to copy the line segment myself. So you kind of see me do kind of a dashed line. I'm trying to draw a straight line. Let me see if I can find a straight edge. I'll do what I can here. Sometimes doesn't quite work on screens. Nope. That was a fail. Sorry about that. I'll do the best I can. But you guys have all the resources with you. There we go. A little bit more comfortable. Okay. So that's kind of seeing what your graph is. Now you can say, oh yeah, I did shift up 2 units. Let's make sure we draw that formally. So you can connect each point with a straight edge or do the best you can with drawing the straight line. And now you have your transformed function. So take a little time with that. Let's do one more together and kind of keep in mind what is happening with this notation. So g of x equals f of x minus 3. Remember that f of x only stands for our y values. So really what we're looking at is y values, and we're subtracting off 3. It's another way to talk about it. So that means what's happening? What's our movement? If y values are being modified, the movement has to be an up-down. And if you're actually subtracting something from a y value, that gives us a clue that we should be shifting f of x down 3 units. And again, if you're a little confused, do what we did earlier with the square root of x plus 2. Maybe you want to do the square root of x and then minus 3, and you can see how it modifies. Totally okay. So if we do this together, let's just modify every single y value, shifting down 3 units. I do some counting. -4, -1 now turns into -4, -4. I'll copy that over to my final draft. -1, -2 now turns into -1, -5. 2, 3 now turns into 2, 0. Copy that over the final draft. And one more point to go. 4, 1 now turns into 4, -2. Copy that over, have a final draft. So now we can kind of see if we're connecting our points with the same line segments that we see. Our graph has indeed shifted down 3 units. So you can make sure we have a nice final draft right here. I'm a little bit off, but we'll work on it. And you now have your transform function, even though you don't know what the name of the function is. So it's kind of nice from there. So practice a little bit more on those. And the next video, we'll move on to horizontal shifting.